What do you say? What is the answer?
A.
Okay. Correct. A. Number 2.
So I can't see a slide, sir. It's jam.
You are supposed to refer to your book.
No. I don't know why your screen like jam already, sir, somehow.
My screen is okay. Something is wrong with your handphone. I can see on my smartphone.
Oh my.
Check your phone. Something is wrong.
One minute, sir. Hello.
Yeah.
Yeah, hello. Okay. Okay. Now can. Okay.
What is the answer? Number 2. Not doing your homework again.
B, sir.
First, replace this one with 1. Then after that, replace these 2 you add together is 2R. Replace this parallel one. Right? Place this parallel one, so it's 2R. These 2 are in parallel. So calculate out. You get 2/3 R. Then after you replace this one, it becomes 1. Then replace the series one. Then you will get that one there. Go and calculate the series one, R and R1. So you get your R2. That's your R2. And this is in parallel. Calculate that. Okay, use your reciprocal method for parallel. So that's your answer, C. Okay. Okay, let's go to the next one, number 3.
So go back number 1 again, sir. Okay.
Okay. Number 3.
So number 3, I don't know, sir.
In the circuit diagram shown below, the power dissipated as E from the 4 ohm is that. Find the value of the resistance R and 8R. Well, first, you are told that 4 ohm and the power dissipated is 4. Then calculate the current here and the potential there. Right? If you know the potential here, you can calculate the potential here. So first part, use this formula for the 4 ohm. Right? Calculate your V1. P is V square over R. So cross multiply PR then square root it, you get your V1 is square root PR. And put in your value 4 times 4 is 4. So if you not got your V1, then you can find your V2. Right? V2 is just your 10 minus your 4 is 6. After I got that, find your current. Right? No need to find your current through here. You can find your current through here because you know the voltage. You can find current. After you can find the current here. They can calculate the current here. Okay, so I1, which is the current through the 8 ohm, is V2 minus your 8. Sorry, V2 divided by 8. And current through the 4 ohm. Right? 4 ohm, we know the potential difference. Or you can use a power formula if you want to. Doesn't matter. You can use this one. V1 divided by that 4 ohm. You get 1 ampere. So 1 ampere through here. And then 0.75 through here. So we can calculate I2. Okay, after you calculate I2, you know your V2. V2 is here. And calculate your R, V2 over I2. Okay.
Sure, Bain. Okay, 1 minute.
You're not making the effort.
Okay.
No excuse because you got model answer in your book there. Not making an effort to learn. How about this one? Yep. Yep. Means you have not been studying at all. You've gone over in class how to find the greatest and the least. Why take so long? Never do your homework. There's a problem with you. Always remember when resistor in parallel, it will always be closer to the smallest one. So if you want the least, then very simple. The greatest, right? In parallel resistor, the effective resistance is closer to the smallest resistor circuit. That's the fact that you must know. Right? So the effective resistance is greater across CD. CD is 10. So the other parallel one, 6 plus 2 plus 4 is 12. So it cannot be greater than 10. It must be less than 10 or closer to 10. Okay, no others. If you take across here, CB then is it cannot be greatest because it must be less than 8 ohm. Then the least one will be 2 ohm. Across the 2 ohm, this 3 replace it with a effective resistance. Okay. Yeah. If you want the least, the smallest is 2 ohm. So all these are in series, add them up. So if they are in parallel, these are 20 parallel to 2 ohm, then the answer will be less than 2 ohm. Okay with that? Yep. What's the problem?
It's basically 2 against 1/18, right?
This is 2. And then the other so resistor will be just add this one up, no? This is 20, no? Yeah. Sorry. 2 plus 4 plus 10. Sorry. My mistake. 2 plus 4. Okay. Any other problem? The first one, you want the greatest one. You see, you find the best. It cannot be across 4. It must be across 10. It cannot be that one there. Cannot be BC. BC, this one is 14. This one is 8. So if you take that as parallel, it will be less than 8. So no others already. The best is 10. So you want it to be less than 10, that's all. Then the least one is this one. So these are in series. Add them up. That's why it's happening here. 6 plus 4 plus 10. In parallel to a 2 ohm. Then the answer must be less than 2 ohm. Okay, what is the problem? What's the problem?
No, actually, because the 6 plus 2 plus 4, they are bigger than 10. Then they put your effective resistance is less than 10.
This one is the greatest one is 10.
Yes.
Then 6 plus 4 plus 2 is, you don't have to calculate out. You know the parallel one is always less than 10 ohm. You can go and calculate if you want to, but this one doesn't require to calculate. Require you to
It's basically 1/6 plus 1/2 plus 1/4, right?
6 plus 4 plus 2 is 12, parallel to 10 ohm. So the answer must be less than 10 ohm. Yeah, that's how you reason it out. Yeah, just using this fact. In parallel, the effective resistance is closer to the smallest resistance in the circuit. So that's why the smallest one is this one, or part B, 2 ohm. And this one is in series. Add them up. That's why I told you must do your homework. You must study the notes I've given you. If not, you will lose. Yep. What's the problem?
No, can go next question, sir.
Go back and calculate. If you don't understand, go back and calculate for each of them. It'll take a long time. Number 5. Kirchhoff's current law.
EMF 12 plus 4.
Say again.
12 plus 4 plus
12 plus 4. Where do you get your 12 plus 4?
The EMF one, sir.
You're supposed to find the equation before you can solve it. So you have to use Kirchhoff's first law first. Kirchhoff's first law you can apply to this junction or this junction. And you can see that you will get a negative answer because they give you the wrong. This one will be probably the wrong direction. Yeah, you get a negative answer. Sorry, yeah. This one is wrong direction. This one, it should be going out. This one we are not sure, right? But anyway, it doesn't matter. You get a negative answer, know that the direction is wrong. How to get the current, how to apply Kirchhoff's current law to point T or point Q? Yep.
The E equals to IR formula, that one. Like the summation of EMF equals to the
Sum of
summation
current, Kirchhoff's first law, sum of current. I'm asking at junction T. They have not been restarting at all. That's the problem. So that's why you are blah. What is Kirchhoff's first law? Kirchhoff's second law. Kirchhoff's first law is at a junction, you add Add the current going in equals current
equals
going
to
out.
0.
So what's the answer? Yeah. At the junction T, what's the current going in? What's the current going out? Current going in is I1, 0.5. Going out is I2. So that should be the first equation to write down. Okay. The next one, apply your Kirchhoff's second law to P, Q, T, U. This loop. Okay, give me the sum of EMF and sum of your PD. Yeah.
12 minus 4.
12 minus 4. I'm giving you the arrow in the direction clockwise. So you must follow my direction.
12 plus 4, 12 plus 4.
But how can it be 12 plus 4? 12 is in the wrong direction. I'm taking the arrow clockwise.
4 minus 12.
Where got 4 minus 12? Where got 4? There's an E here. There's a 12 here. So it must be your E, right? There's a positive, there's a negative there. It must be your E minus 12. That's your sum of EMF. And this current is in the same direction as this clockwise. So it's 4 times I1. That's 4 times I1. And when you move to this side there, this one is opposing that. So that's why we put a negative there. Right? That's your 2 times your this one. That's all. Then we simplify it. Yeah, take the 12 across there. This is minus 1. So still got plus 11. Okay, now we apply it to loop S R Q T. You can use another loop if you want to, the bigger loop. Right? It's your choice. Okay, so what's the equation? I'm taking anti-clockwise now.
Minus 4.
Anti-clockwise, not clockwise. Anti-clockwise, you know why it's anti-clockwise or not? This way, this way. I start from 4. I choose the direction from 4. You can choose clockwise if you want to, but I'm choosing anti-clockwise. So you must be able to write the equation.
Four minus 12.
4 minus 12. Then this is your I1 times 4, same direction. So positive. Then this is the same direction, anti-clockwise. 6 times your I2. Then simplify it. Divide by 2. That's your equation 3. So now you should be able to solve it. Right? As long as you can get these 3 equations, you should be able to get most of the mark. Right? Equation 1 times 2. So you got 2I2. Take this one across there. Times minus 2I1 equals to 1. Okay, so we can add these two together, these two equations, to get rid of I1. So 3 plus 4, right? That one cancel off. So this 3 plus 2 is 5. Minus 4 plus 1 is minus 3. Then calculate your I2. Okay, then after that, you can go and calculate your I1. I1 is from 1, this one. Right? You take this one across there, you get -5. So I2, you got that value. So you get your -1.1. Right? I already told you already, this direction is wrong already. Right? But it doesn't matter. The negative sign tell you that this direction is wrong. It should be opposite, because it's always the power supply that's largest one that should give out the current. That should send out the current, not the current to the 12 volt.
Sure, repeat that again.
Usually it's the power supply that send out the current. Okay. It will send out not the 4 ohm. 4 ohm one 4 ohm one is too small. So it's most likely will send out by 12.
Because the 12 one is bigger.
But it doesn't really matter. Right? It's a 12 one, it will send out the current, not this current going into the 12 volt battery, which is wrong direction. But it doesn't matter. If you choose the wrong direction, you get a negative sign there, that's all. Then you can go to you want to find your EMF. Okay, what have I done? From 2. Equation 2. Equation 2 is this one. Sorry, I think myself about something. What's happening? Okay, from equation 2, right? Here's the equation 2. You calculate your I1, so put in your value. E4, that's your I1, minus 1.1. That's your 11. Right? So you can see 6.6. Okay. You must make an effort to do the question. I cannot learn for you. You have to learn yourself. Okay. Anything? Anything not understand?
Okay. So that means negative sign is to indicate it's always like in
This one shows
anti-clockwise,
that
right? Yeah.
the direction is opposite to what is shown. Put a note there.
It's a test 2 weeks from now, right?
Yeah.
Okay.
Direction of current opposite to that shown. That's all you need to remember. If it's negative sign, that means we choose the direction wrongly.
Okay.
Okay. You should be able to, anything is not clear? Yeah, okay, let's go to the next one. Anything that's still not clear? You have to change in 10 minutes time. Yep. Any problem?
No.
What's the next question? Next question.
Yeah, I think that's it.
That's it idea.
Mm.
Huh? I thought there's got another one. Number 6.
No, I thought like you said, do the one like only don't know.
You must try the rest. It means you are not putting in the effort to learn. It's important you don't do your homework. That's why I say you have not learning. That's why I have to do all the exercise for you. Okay, I think you have not been doing your homework. You better do your homework. This is for your next lesson. No point in me keeping doing all the questions I learned for you. You don't learn anything. So you go and finish the rest. Okay. Take your 5 minutes break. I think I better change the new Zoom.
Teacher.
Okay.
Sir?
Yep.
Teacher.
Yeah.
Sorry.
Make an effort. No progress if you don't make the effort. Okay, we'll stop here. Since our Zoom,
I think the exam is going to be delayed, Teacher.
don't worry about delay.
No. It's not confirmed. I'm just like
Yeah,
thinking
doesn't
because the
matter.
COVID cases. What?
If it's delay, it's delay. It doesn't matter. You still aim as if it's coming in September.
Just do only.
Yeah, just do it. Just prepare for it. So whether it's delay or not delay, it's okay.
Okay.
They will find it difficult to delay because if it delay, they will still have a lot of problem, create a lot of problem for themselves. Okay.
Maybe they just delay 1 month only, Teacher.
Delay 1 month lah. I don't know. Okay, we will stop here. We will start a new Zoom.
Okay. 5 minutes break.